We are starting part 2 of solving linear systems by elimination. Now in the previous video, all of our examples that we did had coefficients of one of the variables that were either the same or had opposite signs to them. But if you look at this first example, part A, neither equation has either variable the same in terms of coefficients. So if I look at these x's, I'm looking at one of them having an 8 and the other one having 2. Definitely not the same, definitely not opposites. Similarly, if I look at the y's, I have a minus 3y and a minus 5y. Not the same, not opposites. So our task will be to make them the same. And how we do that is we're going to take one of the equations, in this case, and multiply it by a constant. And when we do that, we get the exact same line. It's just a multiple. And if you put it in decimals, you'll see that it is exactly the same line when you graph it. Now, the easiest choice here, if you look at the x's, I have 8 x's on the first equation, and I have 2 x's for the second equation. If I were to take equation 2 and multiply everything in equation 2 by 4, I'm going to get an 8x out of that. So here's what I'm going to do. I'm going to take equation 2 and times it by 4. And when I do that, I get 8 x's. Oh dear. Let me try that again. 8x minus, and then 4 groups of 5 is 20, so 20y equals, and then 4 groups of 11 would be 44. Oh my goodness, I'm having trouble here with my stylus. Well, getting used to this new one. 44, there we go. All right, that's equation 2. I'm just going to rewrite equation number 1 underneath of it. So I have them lined up, and then I'm going to look at them and decide, do I need to add or do I need to subtract? Now, since my x's both have positive 8 on them, I know I'm going to need to subtract those two equations from each other in order to eliminate the x variable. So if I take 8 x's and then subtract 8 x's from that, I have no more x's. I have a minus 20y, and then I take away negative, which really is adding 3y. So minus 20y, add 3y would be negative 17y. And then I have 44, and I'm going to take away the negative 7. So I really am adding 7 to 44. And when I do that, I get a 51. And now we solve as usual. I'm going to divide both sides by 17. Divide by 17. And I get that y is equal to 3. Double checking. Whoops. Try that again. 51 divided by 17 equals 3. Good. My mind has continued to be able to calculate. All right, next step, as usual, we're going to sub y equals 3 into, and it doesn't matter which equation you choose. I wouldn't choose the one where I multiplied by 4 because the numbers are bigger there, and that makes it more challenging in terms of doing any mental math with that. I'm going to pick the second equation because my numbers are slightly smaller. I have 2 x's minus 5 times the y, which has a value of 3, equals 11. 2x minus 15 equals 11. I'm going to add 15 to both sides to undo the minus 15. We have 2 x's equal, 2 x's is equal to 26. Divide both sides by 2, and I get x equals 13. So our solution is, the x was 13, it comes first in the alphabet, so it comes first in our ordered pair, 13, comma, 3. Perfect. Okay, take a look at part B and see if you can determine what we can do to eliminate one of the variables. Okay, looking at my two equations, I think it would be easiest, since neither equation has, or neither of the variables have the same or opposite coefficients, I think I'm going to take equation number 1 and multiply by 4. And in doing so, I'm going to make my coefficients, so equation 1 times 4, I'm going to end up with a 4x, which will match up with the x in the second equation. Oh, but wait a second, I also get 8y, which matches up with the y's in the second equation. So I have 4x plus 8y equals 44. And I'm just going to write equation number 2 down underneath of it so we can line up our variables and we can decide if we want to add or subtract. And looking at what I have here, it makes sense that I want to subtract, and that will allow me to eliminate my x variable. And it also, in fact, so I get 0 x's, it also, in fact, is eliminating the y variable. So we have 8y, take away 8y, we're going to have plus 0y, and then 44 take away 20 would be 24. So if I have 0 x's plus 0 y's, that really is 0 is equal to 24. Now, we talked about this a day or two ago. When we get this untrue statement, that means something. And what it means in terms of our lines is that we have two lines that are parallel and distinct from each other. They're parallel lines that will never intersect, and there are no points of solution to this. So therefore, the lines are, are parallel and distinct there is no solution. Okay, now take a look at this part C and see what you can do for that one. Okay, looking at this, I have 4 x's and 3 x's. There's not an easy just multiply one equation by a value to get the other the same. And then I have a minus 5y and a minus 7y. Again, there's not an easy multiplication where I'm just multiplying one. This is a case where I'm actually going to multiply both equations by a value. So let me put some values in here. I'm going to call that equation 1 and equation 2. I think I want to eliminate my, let's eliminate the x's. I'm going to take equation number 1 and I'm going to times it by 3. That's going to make me have a 12x. 3 groups of 5 would be a minus 15y, and 3 13s would be a minus 39, and then 3 times 0 would be 0. And I'm going to take equation 2 and times it by 4. Equation 2 times 4. That gives me my 12x, so now my x's are the same. Minus 7 times 4 would be minus 28, minus 28y. And then 4 groups of 13, that would be 52. So I have a minus 52 equals 0. All right, so since my coefficients are the same, to eliminate them, I would have to subtract. I'm going to subtract my values here. Everything's lined up. 12x's take away 12x's. That one is gone. I have negative 15. I'm going to take away a negative, so that would be like adding 28. So I end up with 13 y's, a negative 39, and then take away a negative 52 would be adding 52. I'm going to end up with plus 13, and that's equal to, and then 0 take away 0 is still 0. I'm going to subtract 13 from both sides. Subtract 13 from both sides. We're going to end up with 13y being equal to 13. Divide both sides by 13. And I get y equals 1. And now we're going to sub y equals 1 into equation, I'll just put it into equation 1. I'm going to get 4x minus 5 times the y, which is 1, minus 13 equals 0. 4x minus 5 minus 13 equals 0. 4x minus 5 and minus 13 go together to be minus 18. And then I'm going to add 18. And I get 4x equals 18. Divide by 4. Divide by 4. That's going to be 4.5 or 9 halves. X equals 9 over 2 or 4.5. So therefore the solution is x is 9 halves or 4.5 and the y is 1. Try the next examples.